Hello, it's Mason Rothman from Project Geo, and we're here at GEOINT 2018. We're here with Eric Truitt from Georgia Tech Research Institute. And Eric, go ahead and speak and tell us what you got this year for us.
Yeah, so just a little bit about Georgia Tech Research Institute. We are a nonprofit. We're owned by the University System of Georgia, and we have about 1,300 resident researchers, mostly in the Atlanta area, and 19 field offices. We have another 700 researchers that we utilize for campus. We do traditional contracting, and we work as a university-affiliated research center, which is known as a UARC. Today we're highlighting something that's not typically associated with GEOINT, which is acoustics. And so behind me we have this is a commercial acoustic beamformer array. So this is made up of several dozen microphones. We actually build our own custom versions of these for sponsors, so government and commercial sponsors that come to us with specific acoustic needs. We build these arrays and put them on various platforms, whether they're airborne platforms or ground platforms.
So you said you're not dealing in the imagery world, you're dealing with the signals or the audio world here. So why are you here demoing that at GEOINT 2018?
Sure. So what we can do is, because we have very precise positioning from these acoustic arrays, using multiple arrays, you can actually get a pretty fine fix on some kind of acoustic target. And so when you match that with the precise location of the arrays themselves, you can actually put audio into a geospatial context. So if you do things like base perimeter detection for UAVs or for gunshots or for other things, we can actually put those on a map and show you exactly where acoustic signatures are coming from.
Phenomenal. So what use cases do you guys have for this so far today?
Right, so we have actually tested this both from a ground perspective. We've been able to track small quadcopters and UAVs very precisely in real time using this. We also can use this to detect certain speakers in conversations. So for example, as we're standing here today, we're looking at a live view of our own voices that are being displayed. But if we were recording this data, the nice thing about the beamformer is in post-processing, you can actually visually select an area where, like for example, my mouth, and hear only my speech, or you can select only Mason's mouth and hear only his speech.
You can see it on the screen here. It's interesting too, Eric, as you were speaking, I can see people light up behind us here, so it can actually hear folks across the room over there.
Yeah, it actually can hear something across the entire other side of this convention center.
Distance.
That's right, distance.
What's the distance on this?
So I don't know what the actual distance is, in an open, quiet space, but I can tell you that it's sensitive enough that they use this in factories to detect air leak detections. So I mean, they can hear moving air and detect that. So I suspect if it was quiet enough in this arena, you could hear basically a pin drop on the other side.
So many
exceptionally
sensitive. Wow.
Yeah.
Okay.
It's another thing we actually did recently that's interesting is we've actually put this on a UAV platform, and from the UAV platform, we've developed algorithms that cut out the UAV and the wind noise, so we can actually fly at hundreds of feet and actually hear conversational level audio, gunshots, explosions, vehicle engines. So yeah,
you pick up that there's conversational audio, or you actually hear the audio.
Both.
Oh, both.
Yeah.
Okay.
And again, like I said, in post processing, you can actually select individual noise sources.
So it's not just a wah that you're picking up. There is audio. You can in fact
again, depending on the laws. So we're still bound by the laws of physics, right? So if there's too much noise, obviously you can only filter so much. But if the sound can make it to the UAV, and within the laws of physics, we should be able to find a way with an algorithm to filter out the noise and listen to that fairly clearly. So
I wanted to ask about the hardware. What's going on behind the hardware here?
So this hardware has some signal processing bits behind it. These are what we call MEMS microphones, so they're very tiny microphones. So
how many total are in there?
I think in this one there's maybe 24 or 32, but we've built them with hundreds. So the more microphones you have, obviously the more precision and sensitivity you get. But yeah,
what's the cost on one of those microphones?
The microphones themselves are maybe a few bucks. Right. So they're actually reasonably cheap. But it's obviously the signal processing software and hardware behind it that is starting to get pricey. But again, we print these on circuit boards, so it's not the hardware that's overly expensive, to be honest. So we can miniaturize this, or we can make larger arrays.
You can large scale deploy this fairly cheap compared to other solutions.
So we actually had one program where we put these on soldiers' helmets, and they're battery powered, and so we could show them through augmented reality where exactly gunshots were coming from. So it's kind of a nice feature and a robust technology.
That is. Excellent. Well, Eric, is there anything else you'd like to speak on what you guys are working on here?
Of course, we do a lot of machine learning, AI type things. So we're closely partnered with the universities. So we leverage the very brightest and best in Georgia Tech, and so we, like I said, among 1,300 researchers. I could talk all day about all the cool things we do, but the point is that we have a lot of 80% solutions, and we're looking for someone to partner with to do that last 20% to make it more specific to a sponsor. And again, we don't build products at GTRI, we just build prototypes, so we partner both with government and industry and just help do cutting edge research and development.
Well, it's a phenomenal product, let me tell you. I hope it does really, really well. I can see my mind already, and probably folks that are watching this as well as applications on how you can use this. I want to thank you so much for your time today, and this is basically Project Geo signing off.
Thanks.